All right, here we go. 2.1 through 2.5 review homework. I really wish I wasn't out for a week. Okay, here we go. Identify the vertex and state the transformations. So your original parabola is y equals x squared. Let me grab a different color. Let's do blue because it's winter. Okay. So the first one is x plus 5 squared plus 3. So these are all, well, meh. Okay, so this one is in vertex form. So remember that equation is can I not be, there we go. Y equals a times quantity x minus h squared plus k, okay? Where h is your x coordinate of your vertex and k is your y coordinate. All right, so the vertex of this guy. Remember, it's the opposite of what you see. So this is going to be a -5. Why is that how it is? Because y equals, this one doesn't have an a, so I'm going to leave it off, x minus -5 squared plus 3. All right, so x minus, and I'm plugging in -5, and that turns into a negative, and a negative turns into a positive. So that's why it's a -5, okay? And then your y is just whatever you're adding or subtracting. So 3. So that's your vertex. All right. So then the transformations. So this is where you can reference the table. So you go to the left 5 and up 3. Okay, I'm going to the left 5. Okay, remember, if it's inside the parentheses with the x, that means you're going left or right. Left or right. Left or right. All right, if it's outside the parentheses, it's up or down. Right? That means it's affecting the y value. So we're going up or down. So this one is to the left 5 and up 3. If you want to use it, write it in vocabulary, it's a horizontal translation of to the left of 5 and a vertical. Okay, that's how you write it, all mathematical. If you write this, I'll know what you mean. Okay, let's go to number 3. Okay, so start by identifying your vertex. All right. So I have x plus 2. So that's going to be a -2. And then my y value is k. So that's -4. So that's your vertex, -2, -4. So that means that you are going to the right 2. Yes. And down 4. No, sorry. To the left 2. My bad. To the left 2 and down 4. So you're going to move your graph 2 to the left and down 4. But then you also have this 2. That means your graph is going to be skinnier because of the in front. Okay, so remember when you're graphing that, you would be multiplying your y values by 2. All right, so it's going to be a skinnier graph. Let's look at, we'll just keep going. Let's look at 4. All right, so vertex is positive 4 this time. And then you're not adding or subtracting anything. So it's 0. So 4, 0. So this one, there's only one transformation to your parabola, and it is you are moving to the right 4. Move to the right 4. Okay. This one we didn't talk about in class. If you have a negative in front of your x squared, or if it was negative there, that means your parabola is upside down. It's flipped. Here, do I still have Desmos up? Oh, I don't know if I can. Oh, I know I can. I can. Maybe I don't. That's okay. Go to Desmos real quick. Okay, so I have my regular graph, x squared. Okay. Y equals negative x squared. Okay, see how it's just flipped? So now instead of increasing, it's just decreasing. So that means all of your y values would just be, your x values stay the same. So, but your y values flip. So this is x is 1, x is 1, oh, y is 1. There it is. X is 1, y is 1. So here, x is 1, y is negative 1. If I can get on it. Oh, there it was. There it is, whatever. So they flip. So then for this one, when x is 2, y is 4. Now x is 2, y is negative 4. So your y values are just the opposite. They all became negative. Okay. Okay, I think that's all I was doing with that. Let's go back to the homework. Okay, so that's what it was. So then this one's going to be flipped, and it's going to be up 2. So let's just see what that looks like on Desmos. Less. Okay. So it's still the negative 1, but now it's just up 2. Here, let's show all of them. So y equals negative x squared, right? So this is negative x squared plus 2, it just rises up 2. Okie dokie. Maybe I should just do a lot of them on Desmos. So let's leave my normal one. But let's go back. If you don't want to see me graph them, you can skip it. X plus 5 squared plus 3. X plus 5 squared plus 3. Y equals x plus 5 squared plus 3. Okay. Yeah. So it goes up 3. That's kind of annoying. Let me make my... Let's go up by ones. No, not there. Here, let's go by ones. There we go. Okay, there. Now you can maybe see it better. So we went from 0 to 3, so it went up 3, right? And it went to the left 5. I'll also make those go up by 1. There you go. Okay, so it went up 3, and it went to the left 5. All right? Okay. There's that one. What else? This one, well, okay, 2x plus 2 squared minus 4. 1 equals 2, x plus 2 squared minus 4. Is that right? Yeah, okay. So your vertex, which we already figured out, is -2, -4. There it is. Okay. So it went down 4. It went to the left 2. Okay. Down 4 to the left 2. And then it's multiplying it all by 2, so it's way steeper. All right, it's increasing much faster. All right, let's see. Okay, hopefully these are making sense. I think I'm going to stop with Desmos for now. Back to this. All right, I think I'm going to leave you with those now. Okay, 7 through 10. Complete the square for the following equations and then write in factored form. These are all going to be, well, you can figure it out, but they're all going to be perfect squares. Let's do 8. X squared minus 18x, and then we have to figure out what this is. Okay, so divide this term in half. -18 divided by 2 is -9. -9, and then square that. -9 squared is -9 times -9. In parentheses. Oh, that works. -9 squared is, oh my goodness, thank you, 81. Okay, let's do one more. We'll do 9. X squared plus 20x plus blank. Okay, to complete the square, you're going to divide by 2. So that gives you 10. And then you have to square it. So this one is 100. Right. Oh, and then write in factored form. I forgot. So when you're writing in factored form, you just take half of your middle term. So it's just x, half of -18 is -9 squared. Okay, and what we learned yesterday, whatever. This is x plus 9 times x. Oh, sorry, x minus 9 times x minus 9. Okay, these two numbers need to add up to your middle term, and they need to multiply together to get 81. -9 plus -9 is -18, and then -9 times -9 is 81. So that checks out. Okay, but if it's a perfect square, you can always just cut your middle term in half, but it has to be a perfect square for that to work. And for this one, it is a perfect square, so it's just going to be half of your middle term. So x plus 10 squared. Okay, once again, that's just x plus 10 times x plus 10. These have to add up to your middle term. 10 plus 10 is 20, and they have to be multiplied together to get 100. 10 times 10 is 100. All right, so that checks out. So you can always double check. All right, that's those. Okay, and these are the ones that we were doing at the end of class today that are not perfect squares. Okay. Oh, see if it lets me do it. Nope. We'll just move all of them down. There we go. Too far. All right, let's start with number 11, maybe. There. Okay. X squared plus 6x plus 12. So you can check if you want to first. So half of 6 is 3. 3 squared is 9. So this is not a perfect square. So x squared plus 6x plus something. And then you're throwing the 12 onto the outside. Okay. So then we already said the perfect square would be 9 here. So to do that, 6 divided by 2 is 3. 3 squared is 9. Okay. But then you cannot just throw 9 into the equation. You have to subtract it out on the outside to keep it balanced. Okay, so then if you want to write it, you can. X squared plus 6x plus 9. And then on the outside, you have 12 minus 9, which is 3. Okay, but you need to write this in vertex form. So this needs to be factored. So just focus here. Write this in factored form. Oh. X plus, cut your middle term in half, 3 squared. 3. Okay, and that would be your final answer. I guess I should be writing f of x. F of x equals, there you go. Let's do 13, because it's right here. All right. Oops. X squared plus 14x. And then we're going to leave that blank, and we're going to throw the 20 onto the outside. Throw your last term onto the outside. Complete the square in the parentheses. So 14 divided by 2 is 7. 7 squared, which is 7 times 7 is 49. All right, but whatever you put on, whatever you add into the equation, you have to subtract it out. Minus 49. Okay, now factor what's inside the parentheses. So x, take half of your middle term, plus 7 squared. And then on the outside, you have 20 minus 49, which is negative 29. Okay, so that would be your final answer there. Bam. I'll do 14. No, I'll do 15. Okay. So, actually, hold on one second. I'm going to pause. Okay, I'm back. So, you want this to be a 1. So you're going to take out your 4. That leaves you with x squared. Okay. If you factor a 4 out of 8x, if you factor a 4 out of 8x, that means you're dividing 8x by 4, which is 2x. And then we're throwing the 11 on the outside. Throw them on the outside. All right. Then ignore the 4 for now. Complete the square inside the parentheses. So x squared plus 2x plus 2 divided by 2 is 1. 1 squared is 1. Oh, so that's 11. But then you're not just adding on 1 into the equation, right? Because you're multiplying all of this by 4. So really you're adding 4 on. So you have to subtract 4 from the outside. Oh, I'm in the way. Why am I over there? Go over there. There. Okay. and then factor inside the parentheses. So this is x, take half of your second term, plus 1, squared, and then 11 minus 4 is 7. Okay, so that would be your final answer for that one. Okay, and see how this is in vertex form? Your vertex would be -1, 7. So you'd be moving this graph up 7. You'd be moving it to the right 1. And you'd be multiplying it all by 4. So it would be a pretty narrow graph. Here, let's graph it. 4x plus 1 squared plus 7. I'm not going to remember that. Losing my voice. Okay. Y equals 4x plus 1 squared. Jesus, it shouldn't be that. Okay, hold on. Oh, there it is. Okay, so it got, goodness gracious, it got moved up 7 and to the left 1. So we'll see how our vertex went up 7, 5, 6, 7, and it went over 1. Ta-da! All right, and then the reason it's so skinny is you're multiplying it by 4, so it's increasing a lot faster. Okay. Here, maybe let's get rid of our negatives so we can see it better. We don't need any negative ones. Okay, 2, 10, 2, 15. Jeez. Let's put -10 to 10. There we go. That's better. Okay. So then you can see it got moved up 7 and to the left 1. And it's so much skinnier because it's increasing a lot faster as you're multiplying it by 4. All right. Back we go. So then state the vertex and graph each of the following equations. Include at least 2 accurate points on either side. Okay. So first things first is the vertex. Which one do I want to do? Ooh. I'll do 17. All right. Oh, I have a spot for the vertex. So the vertex is, just pull it out of your equation. It's going to be 1, 2. 1, 2. So that's your vertex. So actually, I'll go ahead and graph that. I don't know if it's going to let me. Let's see. Maybe. Can I put a dot? Goodness. Little dot? Maybe I should have made this a PDF. Well, let's see if I can just make a little one. At 1, 2. 1, 2. Oh yeah, that actually works really well. Okay, there we go. So I'm at, oh, except I'm at 2, 2. Okay. Jeez. Circle. All right. I'm at 1, 2. Move there. Okay, there we go. Haha. There's my vertex. 1, 2. Goodness. All right. So then that took care of I moved it to the right 1, boop, and up 2. The original vertex would be 0, 0. So I moved it to the right 1 and up 2. All right. But then you have this 1/2. So I'm trying to think if I want to make a whole table. Hold on, give me a second. Okay, so one way to do this is plug in a point on either side. So right now I have x is 1, y is 2. That's my vertex. So go to this side. What if x was 2? Okay, so just substitute into the equation 2. F of 2 equals 1/2 times x is 2, so 2 minus 1 squared plus 2. All right. Okay, so then you have, there we go. F of 2 equals, all right, 2 minus 1 is 1. 1 squared is still 1. So then you have 1/2 times 1 plus 2. Oops, I'll bring it back in a second. F of 2 equals 1/2 times 1 is 1/2 plus 2 is 2.5. All right. So then you can graph 2 and 2.5. Let me make sure that's what I got in my table. Yeah. Okay. Insert do shape. So 2 and 2.5. Oh. Oh geez, okay. Woo. One more time. Insert shapes. 2 and 2.5. Okay, close enough. 2, 2.5. So then you know this is symmetrical, so there has to be another one right on the other side. So there's 2 and 2.5. So then there has to be also on the other side of the vertex, which is 0, so 0 and 2.5 to make it symmetrical. Okay, so you can do it that way. Ooh, by substituting in points. So then you would just go to the next one. I would substitute in 3 for x and solve it, and that point should be at 4. Yes. Yes. Yeah. Okay. So the pattern that you're looking for, or that you can find, is, so from, let me just make a quick little table. I don't know where it's going to pop up. We'll just move it around. Okay, that's not where I wanted it. All right. Bring it here. Oh, that's just made a mess of everything. Hold on. Maybe we won't put a table in. So I went from my vertex 1, 2, and then my next point was 2, 2.5. All right, so I went to the right one and up 1/2. Okay, your next point, you're going to go to the right one again, right? 1, 2, 3, and then up 1.5, which will be 4. Okay, and your next one, you're going to go up or to the right one, and then you go up 2.5. Which is 1. Nope, which is 5. 5. Is 5.5. No, it's not. It's 6.5, which is 6.5. so when you're multiplying the front by a half, that's going to be your pattern. You're going to go up by a half, and then up by 1.5, and then 2.5, and then 3.5, and then 4.5, and so on and so forth. Okay. Okay, so that's that one. And so remember, it's because you're multiplying by a fraction, it's going to be wider than your normal graph. We can graph it on Desmos real quick. Did I graph this one already? I don't think so. Let's go. Okay, no, I didn't. So y equals, I already forgot what it was, 1/2 x minus 1 plus 2. Okay. 1/2 times x minus 1 minus squared plus. Okay, so there it is. Oh, not 1.2. I was like, why is it wider? 1.5. 1.5. There it is. Okay. So you see how your blue one is wider than your red one, right? And then you can look at the points. Oh, well, that's our vertex. And then let's see if I got this right. Click on the actual point. Oh, it's because it's where they intersect. Okay, we'll go over here. There you go, 0 and 2.5. And so this one would be 1. Sorry, this would be 2 and 2.5 if I can land on it. There it is, 2 and 2.5. And then it should be 3 and 4. Yep. And then it should be 4 and 6.5. Yep. Okay. Okay, enough of that. I could mess around with graphs all day. I'll leave you with that.